Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to find indefinite integrals. We are given two of them, and that involve hyperbolic functions. And before we get started, please revisit this table here. Okay, this table is all about the derivatives and as well integrals of basic hyperbolic functions as well. To be able to integrate these functions, you may need hyperbolic identities. This is something that you should keep in a safe because time to time you may refer back to those hyperbolic identities, not only for these questions in this exercise, but for future exercises. Please have a copy of this. And as well, please try to recall U substitutions because we may also refer back to that. And here we go. So why don't we get started? I don't want to give you more hints about that. All right, let's start.
All right, let's stare at part A. It's secant hyperbolic squared 3x. And let's go back to this table that involves the derivatives and integrals of hyperbolic function. Let's see which one is more applicable in our case. So I think we have a secant hyperbolic squared type integral to take care of in part A. So why don't we sort of like make use of this formula here. And this also tells us what to call u in part A. Okay, so I'm going to call u to be 3x to start with, so that du becomes 3dx. Then I can write this integral as secant hyperbolic squared u, and dx is going to be replaced by 1/3 du after this u substitution. And I can pull the 1/3 out. Okay, so in turn I have 1/3 secant hyperbolic squared u du, and this integral is going to be based on the table tangent hyperbolic u plus c. Okay, u originally is 3x plus c. Okay. So this is just one simple u substitution problem, and using one of the formulas listed in this table. Okay. All right, let's stare at part B. We have sine hyperbolic x divided by 1 plus sine hyperbolic squared x dx. So this looks like one of the integrals that we saw earlier, that the bottom of the fraction is the sum of the squares. Okay, so it's like 1 squared plus sine hyperbolic x quantity squared. So why don't we sort of like work through a u substitution out of that and make it look like one of those like integrals that we tackled with earlier. Okay, so here we go. I should probably start calling u to be cosine hyperbolic x, okay? So that du becomes sine hyperbolic x dx. You may think that you should be calling like sine hyperbolic x to be u to start with, but then at the top you have another sine hyperbolic x. That's going to complicate things, okay? So let's go in this direction, see what is going to happen here. So first of all, the top is completely equal to du, because sine hyperbolic x dx is just du. Okay, so what's going to happen to the bottom? So you have 1 plus sine hyperbolic squared x. And at this moment, I want you to go back to the table for hyperbolic identities, and it's the very first identity here, okay? The very first identity here, okay? Cosine hyperbolic squared x equals cosine hyperbolic squared x minus sine hyperbolic squared x equals 1. So, so that implies what? Cosine hyperbolic squared x equals 1 plus sine hyperbolic squared x. So now I can make use of this identity in our exercise here. So that 1 plus sine hyperbolic squared x here is cosine hyperbolic squared x. So this part, let me just write, but I'm going to erase it in the next step. Okay, cosine hyperbolic squared x, right? But that is exactly equal to u squared. Okay, so this question is testing you if you are able to use the identities appropriately towards integrating this integrand. Okay, so now the resulting integral is a very simple integral to integrate. If you write that with the power form, and you can use the power rule for integration here, and that is equal to minus 1 over u plus c. Okay, and going back to the u formulation, if you back substitute u, we have minus 1 over cosine hyperbolic x plus c. And at this moment, you may go back and remember the definition of secant hyperbolic x here. That is 1 over cosine hyperbolic x. So it's the reciprocal of cosine hyperbolic x that takes you to minus secant hyperbolic x plus c. So if you integrate this integral here, this integrand here, okay, so what you're getting is minus secant hyperbolic x plus c. Okay, so that takes care of part B. And remember, we used the power of hyperbolic identities here, not just to decide what to call u, but also to simplify the bottom of the fraction. So make sure that you have a good grip of the hyperbolic identities towards simplifying the integrands. All right. Thanks for watching. I'll see you in another video. Bye.